The field of medical image segmentation has leapt forward in leaps and bounds over the last couple of years. One of the key drivers of this is machine learning. What's happening, guys? Welcome to another episode of Code That. In this episode, we are going to be building our very own medical image segmentation API, which is something that I struggle to find other tutorials for on YouTube. So here I am bringing it to you. In this particular instance, we are going to be using FastAPI, a trained UNet or pseudo UNet, to be able to perform medical image segmentation on cell slides. But as per usual, we've got a couple of rules when it comes to Code That. First and foremost, I'm not going to be allowed to look at any pre-existing code or any documentation, and no Copilot. If I do, it is a 1-minute time penalty. Second, there's the time limit. I've got 15 minutes to get this all done. If I don't, it's a $50 Amazon gift card to you guys. Ready to do it? Let's get to it. Alrighty guys, 15 minutes on the clock. Let's go.
All right, so first thing that we need to do is create a new Python file, and we are going to call this API.py. And then we've got to import a couple of dependencies. But before we do that, I've got a few files inside of here already. So I've got the cancer weights. So these are the weights for the trained UNet model. I've got a model definition, which I would normally just save in a model file. But when it comes to deploying on Heroku, we get stopped by the slug size limits. I'll talk about that more later. And we've also got a test image, which is an image with a couple of cancer cells in there. Okay, back to our API file. Let's make this a little bit bigger. First thing we are going to do is import some stuff from FastAPI. So from FastAPI import, we've got our right environment, FastAPI file and upload file, and then we need to import Tensorflow as TF and then import JSON. And then I'm going to import the segmentation model from this model definition. So from model definition, import segmentation model. Spelled that wrong, DEFINITION. Beautiful. Okay, cool. So that's our dependencies imported. Then we need to create a new instance of our app and set it equal to FastAPI. This is recording. Yep, cool. All right. And then what do we need to do? Think. Then we need to load up our model. So model equals segmentation model. And then we're going to say .model and then model.load weights. And we're going to load up these cancer weights here. So cancer underscore weights.h5. If you want a tutorial on how to build this up from scratch as in the actual deep learning model, let me know in the comments below. All right, cool. Okay. So that's our model, that's our API. Then we need to create a route. So app.post, and then we're just going to set it to the default /post. Then we're going to create a function. So async, and we're going to call it scoring, async def, scoring underscore endpoint. And then that's going to take in a positional argument called data. And then we are going to set that equal to upload file. So we're doing a little bit of typing, and then that is going to be equal to file. ... Cool. All right. And then what do we need to do? So then the first thing that we need to do is take our data and read it. So we're going to be passing through an image in a multi-part form to this scoring endpoint. So we need to go and decode it. So image bytes equals await data.read. Cool. So that will give us our image back in a bytes format. We then need to decode it. So image equals tf.io.decode. I think it's decode image. Yep. Beautiful. And then we're going to pass image bytes to that. And then what are we doing? So that is the beginnings of our model. I want to deploy this to Heroku as well during this tutorial. Okay, so that is that. Then we're going to make our prediction. So y hat equals model.predict, and then we want to expand dims because our model expects multiple images to come through in order to make a prediction. So we're going to go tf.expand underscore dims, pass through that image, and then we're going to set an axis equal to 0. So this is going to effectively just wrap it in another set of brackets, so included in its own matrix. Okay, so then we are going to return a value. So we're going to return a dictionary, actually, my bad. So prediction. And then that is going to be equal to json.dumps. And then we are going to be returning yhat.toList. So I think that should work. All right, cool. Let's try starting this up. So that's pretty much the API done, but there's still a bunch of testing to do. So we first need to activate our environment, and I will include the requirements.txt file so you guys can take a look at this as well. So cancer scripts activate. Yep, you can still see that. Let's clear that. And then we want to run it. So uvcorn, and then we need to pass through the name of the file, so API, and then app, and then -- reload. Just checking you can still see that. Boom. Okay. Crap. Cannot import module app. No, what is happening? Hold up. What did we just run? Oh, it should be API.app. Yes, started. Okay, that looks okay. So you can see that it's gone and loaded up our TensorFlow model there. We're looking good. It is currently running at this particular endpoint. So the beautiful thing about this is that we can actually just go to here. This is something that I found out through just taking a look at some FastAPI documentation. Swagger UI is included. So we can actually go and test out this endpoint and see if it's going to work. So what we can do is just grab the base URL. So 127.0.0.1:8000, and then add in /docs hash or pound symbol and then /, and then we can go and test out this scoring endpoint. So if I go and open this up, you can see it's asking for a request body and it is expecting multi-part form data. So we can hit try it out and then choose our file, pass through our test image. And then if we hit execute, we should get a prediction down here. Boom. That is our prediction, guys. So that is our baseline API now done. So you can see it's actually returning a prediction. But this in and of itself is not good enough for me. I'm happy with this, but it's okay. So what I actually wanted to go on ahead and do is test this out and show you how to run this inside of a Python script. So we could actually copy this request over here. You can see all of this. Copy this, open up Postman. How are we doing for time? We are smashing this.
This is gonna be terrible. I know it.
All right, so open up Postman. Come on, Postman. It's on the other side. All right, that's Postman. And then what we can do is we can actually go and hit import and then paste in our CURL file. So let's just go, how did I do this last time? I think it's just raw text. There we go. So if we paste in that file or that CURL call that we got from FastAPI, we can actually just generate the Python code using Postman. It's sick. So then we just go to raw text, paste that in, hit continue, and then we can hit import, and it's going to generate the call for us, right? So we can now actually test out that API call inside of Postman. So if we go to body, we can actually choose and select our file here. So if I grab or hit select file, choose test image again, and if I go and send that, fingers crossed, boom, that is our prediction up and working. Now that's okay, but again, we still want to go to Python and actually test it out in Python. So over here, you can see does this zoom in? Nope, it doesn't. So if I go and hit code, I can actually get it to convert it to Python, and this is going to give me the requests component. So rather than having to go and do it using Postman or using the Swagger UI, I can actually just copy this request here. And then what we need to do is start up an interface that we can actually go and test this out in. So I'm just going to open up a new command prompt, go into this folder, go into YouTube, go into the Cancer folder, activate our environment, scripts activate, and then I'm going to open up Jupyter Lab. No, not everyone likes Jupyter, but I personally find it to be great. Cool, so that started, and we still got our Swagger UI up there. And then what we're going to do is we're going to create a new notebook. So, and then paste this request in. So let me zoom out because that's a little bit too intense. Why is this not recognizing any? Is it not happy with my environment? No, what is happening here? Oh, it doesn't recognize that environment. We're going to have to go and reinstall. All right, hold up. So what we need to then go ahead and do is pip install. Actually, Jupyter kernel spec. No. Dash uninstall. Oh my God, what is it? Cancer. It should be not dash uninstall. It should be uninstall dash name Cancer. I think we got to remove Cancer. All right, beautiful. So that's removing it, and then we can go peer python -m install pypy kernel. Oh no, it was all going so well. No module name python pip install. Boom. Come on, please. We can make this. 6 minutes. Ooh, this is getting way too close. I'm going to pause it when we try to upload to Heroku because it's a big boy model. I'm going to pause this while it's installed. All right, I've got 6 minutes 19. I'm going to let this install. Ooh, I'm sweating. All right, we're installed. So then we need to go and reinstall this environment inside of Jupyter. So it's python-m ipy kernel installed -- name Cancer. Beautiful. All right, so let's try Jupyter Lab up again. All right, so if you didn't want to use Jupyter, you wouldn't have to go through all that hassle, right? But can't help myself. All right, cool. So then let's paste, let's go back to Postman. Let's copy this. Okay, that looks much better. Okay, so then what we need to do is pass through the file path of our image to this particular value here. So in our case, we can see that we've got test image just there. So I can pass through test image.jpg, and I think this should just work. Let's try that. All right, so it's got a response, but the response is huge. So if I hit response.txt, this is actually going to print out the prediction. Boom! But we need to pre-process that. So we've got to import a bunch of other stuff. So let's import CV2, import, I don't know if I've got OpenCV installed. Import CV2, import JSON, and then from matplotlib, import pyplot as PLT. Damn it. All right, so we are smashing this. We are going to have to install install OpenCV dash Python and then matplotlib, I'm guessing as well. Let's pause it. 4:45. Oh man, I didn't anticipate having to install all this stuff. This is going to be cutting it close. All right, that is it. Installed. Beautiful. Let's go. All right, cool. So that is, let's re-import these. Beautiful, or bueno. So then what we need to do is we need to pass this response, because right now you can see it's encapsulated in strings. So what we can do is grab the prediction and then set it equal to JSON.loads, that response text, right? So now we'll have our prediction inside of a dictionary, all things holding equal, right? So we can check the type. Dictionary, beautiful. And then we actually want to get y hat, right? So y hat equals JSON.loads again, prediction, and then we actually want to grab the prediction key. Boom. So if I take a look at y hat now, should be a NumPy array. Fingers crossed. Come on, we ain't got time for this. All right, cool, beautiful. We got a NumPy array. All right, so then what we want to do is we can actually go and visualize this. So what do we need to do? So we need to go and think. So we've got our prediction. We then need to go and import our image. So image, so x equals cv2.imread, and let's load up test image.jpg. Right, and then y hat, we are going to, we've got our prediction. So what we're going to do is we're just going to render results where our values are above 30%. So TF or NP, do we have NumPy? We don't have NumPy. Import NumPy as NP. np.where. So y hat is greater than 30%, then return 1, else return 0. 1.0. 0.0. I think we need to go y hat to list. Oh no! What's happening? We need to wrap it as an NumPy array. np.array. All right, cool. Let's check that. Y hat. Beautiful. Okay, so now what we can do is we can actually go and visualize this. So fig, comma, ax equals plot.subplots. And then we want to pass through how many subplots. So we're going to have 7 across the page. And then we're going to set fig size equal to, oh man, 2 minutes. We can't get deployment done. Come on, guys, we could do this. All right, and then we're going to go, so ax 0.imShow x, and then we're going to go for x, for class spread in range 6. So we just set this to I. We're then going to go ax I plus 1 dot imShow, and then y hat, we want 0, or get everything, and then we want the actual index of the prediction. I think that should work. Invalid syntax. Boom. Nope, we've got an issue there. What's happening? Number of rows must be a positive integer, not 7. That should be fine.
Sounds good, doesn't work.
Plot.subplots. Ah, they're separate. Doesn't need to be a tuple. Okay, we've gone and screwed something up. All right, so we've got one image. All right, invalid shape. Oh, so we need to squeeze it. mp.squeeze. Boom, boom, boom. Boom, take a look at that. We've got a medical image segmentation. So you can see that this is
nice
stuff that doesn't have cancer. These 5 classes here are cancer prediction. So you can see that it's predicting that these regions have cancer. This little black dot is obviously cancer right there. So we've actually been able to go and make those predictions. Now, the last thing that I want to go ahead and do is deploy this to Heroku. We do not have time, 27 seconds. I'm going to show you how to do it anyway. But in this particular case, that effectively shows you how to build that medical image segmentation API. So we've gone and imported our dependencies, made our prediction, gone and pre-processed it to only show predictions that are above 30% probability. We're then rendering our base image and we're actually showing our classes of cancer coming back. Now we can obviously go and deploy this to Heroku. I'm running out of time, 3 seconds left, but I'm going to show you how to do it anyway because it's in your best interest to know how to deploy it. All right, we clearly didn't make it. So there we go, there's the timer. So we've clearly lost that, but you can definitely go and deploy this to Heroku. So I'll quickly show you how to do that if you wanted to go and deploy it as well. So in terms of deploying to Heroku, so we can actually go, we need to create a couple of separate files. So we're going to create a new file called runtime.txt, and we're going to set this to our version of Python. So if I type in Python down here, you can see we are running 3.9.12. So we would pass through Python -3.9.12. So save that. We then need to create another file called procfile. And this is effectively the call that our API is going to make. So we're going to set it to Gunicorn. Oh, actually, we're going to set it to web :Gunicorn-workers, set it equal to 2-k. And then we're going to set that to UVcorn. Oh man, we were running so well until we had to install all that crap with UVcorn.workers.UVcorn-worker. And then we set that equal to our API call. So it'll be API app. Beautiful. And then we need to go and create a new file call for our git ignore. Ignore, and we're just going to ignore let's zoom in, close this for now, _py cache .ipy nb _checkpoints, and then we don't want to load up our environment, so we can include cancer, and then we don't want to include the image, the test image.jpg, or this Jupyter notebook file here, untitled titled.ipynb. Beautiful. And then the last thing that we need to do is we need to output our pip requirements. So in order to do that, we can do it relatively easily. So it's just pip freeze -requirements.txt. My head's blocking that. Boom. And then you can see we're going to have a requirements file generated up here. We just want to clean this up a little bit. So we don't need to have everything in here. So we really just need FastAPI. So that, and then we need Python multipart, which should be, that's a dependency for FastAPI to upload the image. We want to get rid of PyWin. We then also need TensorFlow CPU. So I had to use CPU because there's a slug limit on Heroku. So you can only upload code, which equates up to 500 megabytes on a free dyno. So I'm going to delete that, and then we're going to delete that. So that's all we really need. So we need FastAPI, Python multipart, TensorFlow CPU, and UVcorn. Beautiful. All right. So that should be us pretty much up and ready to go and deploy this. So then in order to deploy, we can go and let my head blocking that. Yep. So we can then go, so we're just going to initialize a Git repository. So git init, git add all, add dot, git commit, -m, initial commit, boom. Right, so let's just check our git status. All right, so we've got git ignore procfile API cancel weights model definition requirements.txt runtime.txt. We're looking good. All right, so then we can go, so we've already committed, right? Yes. All right, cool. Then we run Heroku login. So this is going to log into my Heroku account. Then I just got to plug in password and username. I can hit enter to open up the browser to actually go on ahead and log in. Come on, buddy. All right, cool. So that's our browser. We can just then go ahead and log in. Beautiful, I'm logged in. It says we can then close this page. We're logged in, so then we go Heroku. Let's just clear this, make it a little bit clearer. So Heroku, create. That should create our instance and create our app. And then we go git push Heroku master. All things holding equal, that should be it. All right, I'll be right back as soon as this is uploaded. So that should go on ahead and upload and then go on ahead and deploy. So we'll be right back. Alrighty, and that is our app deployed. So you can see that it says verifying deploy done, and we've got our link over here that shows where our Git repo is. If we actually just scroll on a little bit up, we can just type in Heroku open. It should give us our link, which will fail because we don't have a get endpoint, but I can actually just copy that, sub it into our Postman request, and all things holding equal, if this does actually work, we should get our response back. Oh no, we've got an error. All right, let's go double check that error. The post, that should be fine. No, we've got an error. We can go Heroku logs -- tail. The logging on here is absolutely horrendous, but anyway. Oh no, we don't actually have an explanation as to what's gone wrong. Damn. We were so close, guys. All right, let me go and debug this and we'll be right back. Anyway, we clearly didn't make the time limit, so here's the gift card. Hopefully whoever gets it first is going to be the one that gets it, or whoever gets it first is the one that gets it. Anyway, let me quickly debug this and we'll find out where we went wrong on our deployment, because we at least got it up there, but it's clearly not working. All right, let me go debug. I'll be right back.
5 minutes later.
Worked it out, guys. Literally one line, and I've got a feeling this is the exact same error that we had in the last API video. Anyway, you can see that this is the post endpoint. We've managed to go on ahead and get our predictions there. There is a bit of a memory leak in Keras, just a key thing to keep in mind. The one thing that caused that error is I didn't have GUnicorn in my requirements for TXT file. So you really need FastAPI, Python multipart, Tensorflow-CPU, UVcorn, and GUnicorn. But you can see that we are successfully making predictions. If I go and make another prediction, fingers crossed, it should work. We might be hitting our memory limits. Just keep that in mind. So there is a bit of a cap and there is a bit of a memory leak in Keras, which I was noticing in the .predict functions. But anyway, that is our model now deployed. We're now getting predictions from our endpoint. So you can see that we are we've successfully gone and managed to successfully deploy to Heroku. As per usual, all the code will be available in the description. Amazing congratulations to whoever manages to get the gift card. I will catch you in the next one. Peace.
Thanks so much for tuning in, guys. Hopefully you've enjoyed this episode of Code That. This one had quite a fair bit of sentimental meaning to me, so I hope you've enjoyed it as much as I have. This is probably something that I'm going to be doing a lot more of in the future in terms of going down this field and seeing what we can do to help push the open source medical community along, if that is a thing. Anyway, thanks so much for tuning in, guys. Hopefully I'll catch you in the next one. Peace.